Okay, now starting SmartPLS. Before going into SmartPLS, let's talk about a few basic things, because I know a lot of people would not have used SmartPLS or would not have even made a basic model in SmartPLS. Let's say this is my questionnaire. I normally format my questionnaire like this because this gives me a lot of space to put in the items and everything. So let's say this is my questionnaire, and I've circulated the questionnaire and I've given it to 500, 600, 700 people based on the total population or the expected population or whatever, and I've formulated and then they have responded to my questionnaire, and I've got like say 300, 400 questionnaires back. Now when I got my 300 or 400 questionnaires back, now the first step is to enter this questionnaire into any software so that we can further use it for analysis. We can put it in Microsoft Excel, we can put it in SPSS. These are the two softwares that we normally use. There are others as well. For example, there is Jamovi as well that you can use to enter your data. It's a free to use software. There are videos on my channel on Jamovi. There is Blue Sky Statistics, another free software based on the language R, that you can use it as well. But the most easiest of the softwares are Excel and SPSS. Now let's say you've collected data and you've got 300 papers in front of you or 300 questionnaires filled in front of you. The next step is to enter this data into an Excel or SPSS sheet. The focus of this workshop is not on Excel or SPSS sheet for today, but just to give you a background as to how it goes, I'm just going to brief you about it just a little bit. Let's say we are using Excel, and let's say I open an Excel sheet and enter my data. I would strongly recommend that you use SPSS to enter your data so that you can check the anomalies in your data, if there are any errors in your data. You can do it in Excel as well by looking at the minimum or maximum value, but then you will have to enter formula, and that sometimes is a job that takes time. Let's say this is the empty Excel sheet that you've got. So what you do is, for instance, this is my questionnaire. So these are my variables. Now this is another variable, ethical responsibilities, and it is operationalized using these 8 items. Research development responsibilities operationalized using these 7 items. Philanthropic responsibilities operationalized using these 6 items, and same is for others as well in your study. So what you do is, for example, you first define the variables in the column: age, gender, let's say education. And for ethical responsibilities, let's say I code it as ER, and this one will be referred to as ER1, this one as ER2, this one as ER3, so on and so forth. This one as RDR1, RDR2, so on and so forth. So what we do is just put them in here. Let's say ER1, ER2, so on and so forth. Now I've got my first questionnaire. So what you need to do is, while you are entering the data, it's always a good idea to put a code on the top of your questionnaire. For example, this is row number 2 in this case. So what I'll do is, at the top of the questionnaire that I'm using, maybe on the left, right, at the bottom, on the back, you will mention the number 2. So if there are any problems in the data while you are entering, you can refer back to that particular questionnaire sheet and see what was the correct option that was chosen by the respondent, so that you do not lose onto the valuable data that you have. So once you have defined all this data row by row, each row represents a single respondent. And once you have defined all this data, it should look like something like this. So it should look like this. Here is the data. I've got around 341 responses. So So once you have entered the data, the next step is obviously if you are using any software, maybe in this case we are using SmartPLS, it's the next step is to import the data into SmartPLS. But before going into the detail of what is or how to use SmartPLS for data analysis, just a few just a basic introduction to SmartPLS. Basically is a software that is that uses or is based on structural equation modeling technique. Now, we've all seen these models in different papers. This is actually made in Amos. So we've all seen these models like this, something like this, something like this. So what is SEM, structural equation modeling? And why has it got so much fame that none of the journals now almost accept papers without having SEM. Almost, I said, because there are other techniques, other tools, other ways to do data analysis as well, and not primarily only SEM. SEM has got its own criticism. It is a symmetric method, so it does not explain or well explain the combination of conditions that can lead to an outcome. That's why we need asymmetric methods that are gaining increased focus. I've been using asymmetric methods quite a lot these days in my papers, because the symmetric methods obviously have got their own limitation, but still it's the most popular method or methods being used. So, and even at MS level, PhD level, writing papers for different quality journals, still it is the most famous method. So what is SEM? So SEM is a general statistical modeling technique used to establish relationship between variables. So it's a technique, a modeling technique, something that you use to model the relationship that you think exists between different variables in your study or proposed variables. Now it's a combination of factor analysis and regression, but at the base of it is regression. So everything is with respect to that arrows that we draw normally in regression analysis. Now, researchers initially relied on univariate or bivariate analysis, a simple descriptive statistics, or maybe correlation analysis, or simple linear regression analysis to understand data and relationship. But those analysis or those techniques could not handle complex relationship. They were limited in their application and could not handle multiple variables at the same time. Obviously, you can say that multiple linear regression can handle multiple independent variables and a single dependent variable, and these are multiple variables, but they are not complex relationship that can be tested using a simple first generation software like SPSS. So you need, or we needed, something that could be all inclusive, and you do not have to check every relationship separately. Like for mediation, we had to have a 4 or 5 steps testing a mediation analysis, or if you're doing regression, you have to check IV with MV separately, MV with DV separately. To a certain extent, process and Hayes macro did solve the problem, but still there were other issues like measurement model issues with process and Hayes macro that were later solved, or actually rather the solution is in SEM. So multivariate analysis involves the application of statistical methods that simultaneously apply or analyze multiple variables. So you can put in number of different variables. Now, for example, in this model, we've got 1, 2, 3, 4 variables in a single model with complex relationships. Servant leadership affecting these two plus this other one, this variable, psychological climate affecting the other variables in the study as well. So you cannot model this variable or this relationship or these relationships in SPSS. Now for this, you need a modeling software, an SEM software that could be maybe, let's say, M+, it could be R, it could be PLS-SEM, Adenco, maybe VOR-PLS, Amos, or any other software that you can think of. These second generation software, they can be utilized to do these things. Now, there is a concept, obviously you would have heard about it, EFA and CFA. So EFA is exploratory factor analysis and CFA is confirmatory factor analysis. So when do we use EFA and when do we use a CFA? When applied to a research problem, these methods can be used to either confirm a priori established theories or identify data patterns and relationships. Specifically, they are confirmatory when testing the hypothesis of existing theories. So if you've got an existing theory and you are testing the hypothesis that you have proposed based on those existing theories, you are doing your CFA. And exploratory when you are searching or when they search for latent patterns in the data in case there is no or only little prior knowledge about how variables are related. For example, there is a concept, let's say entrepreneurial leadership, let's say knowledge management leadership or knowledge oriented leadership, or let's say there is a concept university social responsibility. It's a new concept with very little knowledge as to what makes university social responsibility. What is the makeup of university social responsibility? Somebody might be writing a paper in which they have proposed that, okay, these are the dimensions or could be the dimensions of university social responsibility. Now, in order to make sure, yes, this is what or this is or these are the dimensions of university social responsibility, what one can do is, after data collection, they can test whether yes, in actuality these are the dimensions or not. So when exploratory factor analysis is applied to a data set, the method searches for relationship. Variables with high correlations are grouped together. By variables, here we mean indicators. So indicators having high correlations are grouped together and then they make up the factors. And all these factors can be referred or make up the scale for, maybe in this case, the example is university social responsibility. So what it does is help you reduce the large number of variables into small number of factors. And the final set of composite factors is a result of exploring relationship in the data and reporting the relationship that are found, if any. And then those factors can be linked with other variables, and you can obviously test your hypothesis if you are testing any. Now, whenever we're doing SEM, basically there are two types of models. One is your measurement model, and the other is structural model. The advantage of PLS-SEM is that you can test both these models by making one single model. So it can differentiate between this measurement model and structural model on its own. The measurement model is referred to as the outer model in SmartPLS, whereas the structural model is referred to as the inner model. So what entails measurement model and what entails structural model? So measurement model is about examination of the latent variable and their measures and its indicators. The objective of measurement model is to assess the quality criteria of the constructs that you are using in this study. And by quality criteria, we simply mean assessing the reliability and validity of the constructs. On the other hand, a structural model is about testing the relationship between latent variables. So if you have hypothesized a certain relationship, it is tested using structural model, and it is utilized to assess the significance of relationship between different latent variables in the study. So these two models are basically the root of structural equation modeling, even when you are reporting your results. So when you are reporting your results in a paper, in a thesis, you divide your analysis into measurement model assessment and structural model assessment. And during your measurement model assessment, you focus on establishing the reliability and validity of the constructs. These are two different constructs and they are not used interchangeably. And we'll be talking about these and their differences as well. Now, structural model is about testing the relationship between those latent variables that you have proposed. For example, this is a structural model testing the relationship or impact of servant leadership on OCB, SL on JB, psychological climate on job satisfaction, and job satisfaction on OCB and other relationships. So now, moving on. Now you've got the data. And now you know that what is SCM, what you are looking forward to, and how now we are going to focus on how we can use it. Now this is SmartPLS. In my case, Actually, you will see a lot of projects in here. So this is the project explorer. Obviously, once you have installed it, you just need to just double click here, SmartPLS3, and your software will open. It's a free to use software for 1 month. Afterwards, you can use only 100 rows for unlimited time. But at the end of the day, obviously 100 rows is not enough when you are writing your paper or thesis. So what is obviously it's not that expensive, but still it is very expensive. These days the price is 22 euros. That amounts to around 5,000 rupees. So if when needed, you can purchase the software and use it. Otherwise, it's free for 1 month, completely free, and it's with all the features. Afterwards, obviously, you will have to purchase it. Why SmartPLS is being used increasingly? There are a number of reasons. One of the most important reasons is it's very easy to use. Really easy, very basic. Obviously, if you do advanced analysis, obviously things get complicated. But in comparison to other softwares, it's easy. It can have higher order constructs, both reflective and formative. Third, the presentation of results is really easy. Fourth, and sometimes that is the main reason people are using it, the results. Your loadings are when you are using covariance based SEM like Lizral or Amos or R or Lavan R or Amos, your loadings and your the factor structure or the validity or AV values, they do not turn out to be good. The loadings are not that good. But in case of PLS-SEM, your loadings are more or less, they are good. This is what my experience is. Now moving on. So once you open this software, so this is what you will see. You will see a project explorer here. And in your case, if it's a new installation, obviously you might see just 1 or 2 archive projects or something like that. This is your indicator window. So all these are the indicators. Indicators for what? Indicators for this particular construct. These are indicators for this particular construct. These are indicators for this particular construct. So let's say we want to create a new project once we have opened SmartPLS. So what you need to do is you need to click this new project button here. So let me click this and it will ask me for the name of the project. So let's name it workshop. Once you click OK, and here is your workshop project. You can see the exclamation mark here, obviously because you haven't imported the data yet. So what you need to do is you need to double click to import your data. Now there is one important thing here that one should note, that SmartPLS will accept a comma delimited file, comma separated version. So do not import a SPSS file, .sav file, or a .dat file that we normally use in M+, or an Excel file, a .xls file extension. So use a .csv file. So what you can do is just, if you've got it in Excel format, just go to File, Save As, and select CSV extension, comma delimited a CSV file, save it, and then you can import it. In this case, I've already saved it. Here is the data. So what you can do is double click on it, or txt file is also available, but use CSV format. So it's saying thesis data is the file name. Yes, it is. And here is the summary. And so once you see this, your data is all right, and it's now imported. You see that this cylinder will turn green. So your data is imported. This is the file name, and there are 341 respondents. So this is all correct. Now it's always recommended to have a look at the minimum and maximum values so that there are no errors that you can find that yes, my data was entered correctly. For example, instead of 1 or 7 there could have been 1 and 77, so there is a problem with your data. Now these are the mean values. Obviously age mean is fine, you do not go for the mean of the gender. The years is fine. I don't know what is rank. You do not go for the rank because it's a categorical ordinal variable. Tenure is fine. System, no need, it's a nominal variable. Bank, nominal variable. Type, nominal variable. Now these are all the means for the constructs. The median values, the minimum, maximum, this is the standard deviation and distribution, skewness and kurtosis. Obviously, one of the reasons to use SmartPLS as we do not have the assumption of normality. So even if your data is not normally distributed, you can use SmartPLS, and that's the reason it is used or preferred to be used. There is no normality assumption. Okay. Now that you have imported the data and it all looks very good, the first step is to make up your model. So you go to this here, this model here. You double click and you get this canvas. Here you draw your model. On the left hand side, when you click this, double click this model, you will see all your indicators lined up. So there are 84 indicators in my model. And let's say, and then here are the other details that you can obviously will be using from time to time when needed. Now let's make a very basic model, our first model. Let's say I've got one IV and one DV, and my IV is, let's say it's organizational learning. So what you do is you select the indicators from OL1 to OL8, and these are the 8 indicators that are measuring organizational learning. So what we do is we select them, or just select the first one and move to the last one using shift key, and all will be selected, or otherwise use the control key to select each one of them separately. Once they are selected, you drag them and drop them onto your canvas. Drag and drop onto your canvas, and here you will see that these are the 8 indicators that are measuring this latent unobserved variable, which is observed using all these 8 indicators. Now it shows that it is latent variable 1. It's always a good idea to rename them, but we'll rename them later. Let's say our other variable in the study, that is our dependent variable, is organizational performance, measured using 5 indicators or 5 items. So once selected, we drag them and put them here. Now snap it to grid so that you can easily arrange these constructs. So if you do not snap or do not do a grid snapping, then it's slightly difficult to arrange. So I prefer doing it using snap. So once you snap it, it will show you proper arrangement for your model. Let's move these indicators to the right. So you align them, align indicators to the right. So you have selected your construct and now you align it to the right. You cannot run the model now. Reason being, it's red. And why it's red? Because there is no relationship between the latent constructs. So what you do is you first rename them. It's always a good idea to rename your variables. So in order to rename them, just right click and click a rename, or press F2 or function F2. In this case, I've right clicked it and I'll click a rename and I'll name it organizational learning. This variable is organizational performance, so I'll right click on it, rename, and name it as OP. Now once the renaming is done, now the next step is that you connect these two variables. How do you connect these variables? Here on the toolbar, you will see there is this option of connect latent variables, or the shortcut is Alt+3. In this case, let's click connect, and the arrow or direction of arrow is from this variable, which is your independent variable, to this variable, which is your dependent variable. Now I'll just press it on the independent variable and drag it and drop it on the dependent variable and click to drop it. Now it has turned blue. This means that now you can run your model. Now we can run our model. So as I mentioned that in SmartPLS, your structural or measurement and structural model are tested all together. So in this case, this inner model, this is our structural model, and this is your outer model, your measurement model. In order to run this, what you do is we go to calculate and we go to PLS algorithm. In order to do this, we go to calculate and go to PLS algorithm. Now you will come across different options now, centroid, factor or path. So you can select path or you can select factor as well, but now these days the experts say that it's always a good idea to select path. Waiting, just leave it as is. Maximum iteration, normally it's recommended to go up to 500, but this is 300 is fine. If there is an error and it says that more iterations are required, which you hardly will, you will hardly get, so you can increase the iteration, but we are not focusing on these things for now. Just click start calculation. Now that you have made your model, the very basic model, click calculate PLS algorithm and just click start, and the model will run and you will be presented with an output. PLS algorithm, this is your run number 1, and here are the different results that you can look into. By default it will take you to path coefficient. We see that this path is showing 0.633. this is the weight of impact. It looks very good. If we come back to the model here, workshop.SPLSM, if you look here, the weight of impact is 0.633. This is significant, looks very significant. Obviously factually we'll have to check the p-value, but this is heavy. What is this? What are these numbers? What are these numbers? And what is this number? Now when you are running PLS algorithm, the objective is to assess the measurement model. The objective is to assess the quality criteria. How do you assess the quality criteria? The focus is on assessing the reliability and validity of the constructs. By reliability we mean consistency. By consistency we mean that if this study was to be conducted at another time with the same subjects under same conditions, would the results differ or would the results still be the same? So consistency means testing your model or using the same construct or with the same subjects in the similar conditions. If it yields different results in every single test, this means that these constructs or these measures are not reliable. They do not yield consistent results. Whereas validity, it's about whether the construct measures what it is intended or what it intends to measure. Now obviously this is statistical validity. There is other validity as well, and that is content validity, and that should be assessed obviously before you collect the data. For example, you are collecting data on a construct, let's say job satisfaction, and you have prepared a questionnaire. Now when you take that questionnaire to the experts and the experts look into the questionnaire and they say that, well, this is not actually measuring job satisfaction, rather than it is measuring the motivation to the job rather than the feel good factor about the job or satisfaction about the job. So that is obviously done through experts, but statistical validity is done through different statistical softwares. Now, once you have run this run this analysis, run your basic model, and this is your measurement model, the first step is to assess your construct reliability and validity. Look whether your constructs are reliable and valid as well. Now, there are the first thing that we are going to look into is reliability. Now reliability is assessed using, there are two methods to assess reliability. One is Cron-Batch as alpha, that has been used for quite some time now. And the other is composite reliability for the construct. So this is the Cron-Batch alpha. Obviously, the threshold value is 0.70, and in this case, we see that both our constructs OL and OP have got or surpass the threshold of 0.70. So we can say that our reliability is excellent. Now, leave this row. Although this is green, this is good. So, but we do not normally report a row as well. The next or the second type of reliability or second method to report reliability is composite reliability. This is 0.931, 0.935. This is again greater than 0.70. So we can say that our measures that we are using in this study are reliable. There is construct reliability. So you have achieved the reliability for the constructs or the measures that you are using in this study because the threshold value of 0.70 is crossed. Now, how do we calculate composite reliability? Because this is Cron-Batch alpha is an old method that we have or all might have used during our usage of SPSS. Composite reliability is calculated based on factor loadings. So what is factor loadings? And we already mentioned that everything in these SCM based software is actually comes down to loadings or factor loadings. So what is factor loadings and where we can see factor loadings? Since it is statistics and since it is numbers, you will always have threshold for everything. There is threshold for every single thing. So where is factor loading? What is factor loading? And what is the threshold for factor loading? What happens or what should we do when these are not green but rather they are red? What is obviously we'll be coming back to this part here later, just in a minute. So what if these are red? Before going into that detail, how to troubleshoot your model, let's look at the loading. So this number here, these numbers here on the arrows pointing towards these indicators, this is these are loadings. These are referred to as factor loadings. What do you mean by factor loading? Factor loading means, in simple terms, how well this or these particular items represent this underlying construct. Factor loading means how well these indicators represent this underlying construct. The threshold for factor loading is 0.70. But what happens if the threshold is not crossed? In this case, for these two indicators, it's not crossed. So what should we do? Shall we delete them? No. You do not go on this deleting spree. You delete it only if they are required. And what's the requirement? We'll be talking about this. So what is factor loading? How well these indicators represent this underlying construct. Same for this. How well these 5 indicators are representing this underlying construct of OP. So this is what we call factor loading. And this is obviously this is the assessment of the outer model. Now we know that, okay, this is weight of impact, the impact of OL on OP, the weight of impact, the beta coefficient as we normally call it. These are factor loadings. Now what is this number here? 0.400. This is your R square. This is your R square, which actually tells you how much variance, how much change in this dependent variable can be accounted to this independent variable here, based on obviously these factors or these items. So 40%, if you convert it into percentage, this will amount to 40%. So 40% change in organizational performance can be accounted to this variable here, organizational learning. Now, so this model here, and we have assessed the reliability, and we have used 2 methods to assess reliability. One is alpha, one is composite reliability. Now, before going further, let's see how do you report this in a paper. Now, if you're doing a thesis, it's always recommended that you briefly explain what reliability is, what methods are you using, and what are the threshold values. So just give your reader a background as to what it means, how you are going to use it. But such requirements are not obviously can't be met in a paper. You can't just go on defining every single thing that you are writing, because this is a research paper. You have got limited space to do it. Now, how do you do it in a research paper? How do you write your data analysis and results section? So as mentioned, we start with, and this is our data analysis and results section, and we start with the measurement model. And then once the measurement model is reported, I'll tell you how to report it. The second step is your structural model. And within, obviously, then if you've got mediation, I normally prefer reporting mediation separately. You can obviously report it with the structural model as well. Won't make much of a difference. But in order to add more clarity, readability, I like reporting my structural model, obviously my mediation analysis separately. Now, how do you report it? The measurement model displays the relationship between the constructs and the indicator variables. So what is the construct and what are the indicator variables? These are your constructs. And for these constructs, these are the indicator variables. So how well are these indicator variables linked with this construct is the assessment of your measurement model. As part of the measurement model evaluation, indicators with low factor loadings were removed. Now, the first thing that you do when you are doing your measurement model assessment, you keep a threshold to remove loadings. Now, the desirable threshold or the desirable value or the desirable loading value is 0.70. You can go for 0.60 or 0.50 or 0.40. So if anything, so now how do you decide whether to remove an item with low loading or not? Now, in order to do this, what you need to do is you need to check the validity of the construct as well. Now, if you find that your indicators or your construct is valid, now what is validity? Obviously, we've talked about it. If the construct is measuring what it is intended to measure, then this is the construct is valid. How to statistically determine validity? So construct validity is determined using two forms of validity. So you actually determine two forms of validity to establish construct validity. One is convergent validity and the other is discriminant validity. So there are two forms of construct validities. One is convergent validity and the other is discriminant validity. These are two forms of validities. They are that should be or shall be assessed in a research paper when you are doing a survey-based research. So how do you assess convergent validity? Let me move it onto another paper. So the method to assess convergent validity is average variance extracted. We normally refer to it as AVE. And let's talk about AVE first and then we'll get to discriminant validity. So in order to test convergent validity, we have to check for AVE, average variance extracted. How much variance in this construct can be accounted by these 7-8 indicators? Same goes for this one. So what's the average extracted variance in this construct because of these 8 items or indicators? So this is your average variance extracted. The minimum value is that it should be greater than 0.50. The value should be greater than 0.50. In this case, if you look here, this is greater than 0.50. Now, how is this calculated? I'll be showing you the formula now in a minute. So in this case, if you look here, we've got two constructs here. One, this construct, the other one, this construct. And those two constructs have got convergent validity established. Now, what is convergent validity? This is your construct, organizational learning. Let me zoom in a bit. Now, this organizational learning construct is measured using these 8 indicators. These 8 indicators, are they coming together? Are they converging to measure this underlying construct of organizational learning? Obviously, since they are measuring the same underlying construct, they should come together, converge to, or rather in simple terms, correlate to measure this underlying construct. In some of the tutorials, even on the internet, you will find correlation as a measure of convergent validity. If there is a higher correlation between these indicators, not to an extent that it shows multicollinearity, they say that it is convergent validity, but a more sophisticated method is AVE. Now, so if you look here, this is OL1 to OL8, 8 items. Are they converging together? The answer is yes, they are converging together. They are coming together because the AVE value is greater than 0.50. The AVE value in this case is 0.629. So this shows that convergent validity for this OL and this OP is established. So AVE value greater than 0.50, so your convergent validity is established. Now, before going into further detail, let's see how it is calculated. So when I used to use AMOS, or when I use R, or when I use M+, because then you have to calculate it on your own. So I've developed this small calculator here. So what is the formula? So what you do is you take square of each of the factor loading and then you sum those squared loadings here. For example, this is the loading and this is the square of the loading. Let me zoom in a bit so to make it easier. So this is your factor loading, this is the square of the loading, factor loading, square of the loading, factor loading, square of the loading, factor loading, square of the loading. All these loadings added up, divided by the number of items, you will get your AVE. So this is how you calculate your average variance extracted. Now, what's the reason that it has to be 0.70? Why not 0.80? Why not 0.60? Because you will not get this threshold passed if the loading is less than 0.71 or 0.70. For example, if let's say 0.70, 0.7, let's make one of them. Okay, it was some 0.703 or something like that. Anyway, let's say put this one here. So now we see that AVE is 0.50. So you need a loading of at least 0.70 in order to make sure that all these constructs will converge and they will have a AVE value of 0.50. What if a particular loading is less? Let's say, what if this loading is 0.65? And what if this loading is 0.75? 0.72? You still get the AVE value of 0.50. Now, although this loading is less, factor loading is less than the threshold that is recommended for this item to be adequately representing the underlying construct, although this loading is less, but still your overall AVE is greater than 0.50. So you do not delete this loading. Normally, as recommended, you only delete loadings when they are less than 0.40. If they are less than 0.40, even if the AVE is higher, obviously they are not adequately representing the underlying construct. In some cases, I've read somewhere it is even 0.3 as well. And then even when you are deleting, you do not just go on and delete your items. Sometimes I come across people who are deleting items just to achieve the AVE values, but then they are compromising on the content validity of their construct. You cannot compromise on the content validity of your construct. So in this case, we are not deleting any item, although this is less than the threshold. So this is how your AVE value is calculated. Now how they are reported? So you start this and then you measure or you mention the loading, less than loading that has been removed. I normally write 0.60, but I do not, or 0.50 as recommended in different papers, that okay, any loading less than this was deleted. But you can keep the threshold high if there is no loading less than 0.60. So you can keep the threshold high. If there is a loading that is less than 0.60 but greater than 0.50, then I will keep my threshold to be less than 0.50. So this is subjective, just to make sure that your quality criteria was more strict and was not much of a liberal sort of criteria. In this case, one item was removed from the analysis due to low factor loading. The first component of the measurement model is the reliability analysis. So the first thing that one does is reliability analysis. And what you do is you report your reliability, alpha value, loadings, AV. If you're writing a paper, more or less in a research paper, what you do is you combine all this measurement criteria into a single table. Although this is given separately in your results of SmartPLS. For example, where are your loadings? If you come down here, final results, and look at outer loadings, here are your loadings, outer loadings. So you take out the loadings from this table and you take this table, you combine these two tables to make one single table like this. So it saves you space and the word count as well to a certain extent. And then you explain, okay, now this loading bit is done. The first component of the measurement model is the reliability analysis, which includes composite reliability. The desirable cutoff value for composite reliability is 0.70 according to Ringel et al. 2018. So you mentioned that why this cutoff? Because experts have mentioned this cutoff. Consequently, all the latent constructs of the model possess composite reliability. How? This is shown in table. If you will look here, all the constructs have got composite reliability because the reliability is greater than 0.70. The second component of measurement model is convergent validity. So you now assess the convergent validity. How do you assess convergent validity? You assess convergent validity through AVE, average variance extracted. Now if you look here, all of them have got greater than 0.50. And yes, the quality criteria for convergent validity is established, hence the constructs possess convergent validity. But what if you are writing a thesis? So let me give you an example. So if you're writing a thesis, obviously it's a total chapter. It's not just a section in your paper, so it has to be much detailed. So you start your thesis with the introduction. You start your thesis with the introduction as to what this chapter does and what it includes, what sort of hypothesis it checks. Then you present your demographic profile of the respondents. Obviously their SPSS or Excel is used to present these sort of results. Then you can present the descriptive statistics of each of the construct using SPSS, or maybe again Excel can be utilized as well. EFA do not need it when you are doing it is based on existing scales. Now here is your model evaluation. So here is your model that you want to check, and you start with your measurement model. Now if you look here, I've reported factor loading separately. This is factor loadings. Multicollinearity separately. Reliability analysis with description as to what it means, why it's important, and different ways to assess it, and the quality criteria and all those separately. Your validity, your construct validity defined, your convergent validity defined, explained what it means, and then reported. And obviously then we are going to discriminant validity as well. But since you've got space in your thesis, you report each of these analyses separately in much more greater detail. Obviously, the way you present it, the sections to include, the sections not to include will obviously differ based on the university where you are studying, the supervisor that you are working with, because obviously things change with people or supervisors. If you go to pure statistics people, they don't even like when we used to use SPSS back in the day, they used to say you can't even use regression analysis because the Likert scale or Likert scale is on ordinal level, but we used to assume according to Nunnally that the distance between the options is assumed equal, so we are saying that this is interval scale, so we can use the regression technique. So obviously these things change with supervisors. The opinion change from person to person, from supervisor to supervisor, from people to people. A number of people they um, uh, like the introduction differently. People like their analysis done differently. So obviously you have to take that into consideration as well. So this was all about your quality criteria for and with convergent validity. Now there is another form of validity as well, and what we call it is discriminant validity. Now where convergent validity assessed whether the indicators are converging, coming together to represent the underlying construct. Discriminant validity is about differences or discrimination or distinctiveness of constructs. If I like put it, whether the constructs in your study are actually distinct from each other and that they are not measuring the same thing, they are not similar concepts. So discriminant validity is to establish the distinctiveness of your constructs in your study. Now there are different methods. Previously there was only Forner and Lacker criterion. Cross loadings, obviously with the you could have used it as well. But recently there is HTMT, heterotrait monotrait ratio. So there are these three methods are now utilized in research, and I try to obviously report all these in my study. Sometimes obviously I do not report cross loadings sometimes, but normally I do report Forner and Lacker and HTMT criteria, and this is how I report it in one single table, combine both of them in a single table. I'll talk about this in a minute, but first let's look at discriminant validity. Now here are two constructs in your study, OL and OP. Now these two constructs must be distinct from each other. These two constructs must be distinct from each other. They should have their own individual identity. Now how do you establish discriminant validity? Again, I have mentioned that there are three ways to do it. Forner and Lacker, it was in 1981 if I'm not wrong. There is cross-loading and there is HTMT. Now where is this in this output? If you go down here, you will see discriminant validity. And if you see this is Forner and Lacker criterion, then this is your cross-loading, this is your HTMT, and this is your chart or graph for HTMT. Then this is green, so there is no issue. Now let's say Forner and Lacker criteria. Now let me copy it onto Excel, that it will be easier for you to understand. So just you can, if you've got a licensed version, you can copy it into Excel format. Open your Excel sheet. Let me use this. Put it in here. I hope everyone can see. Now, what is this, which I've marked in bold and italic? This one here. Now, and what is this? So first, let's identify, let's understand how discriminant validity is established, and then we'll look into further detail as to what this means, and what this means. Now, if this top value, the top value in the column, must be higher than all the values underneath. In simple terms, just for understanding for now, based on the results or the format of results this particular software is giving us, this here, this value 0.793, the top value in the column must be higher than the values underneath. So if this is the case, your discriminant validity is established. Let me repeat it and then I'll explain what these values mean. So if the top value, the column, the value in the at the top row, the top cell in the column, if it's higher than all the values underneath, you will say discriminant validity is established. Now, having said that, now let's go into detail as to what these values mean. And what if there is no value underneath like this? What if the values are on top? What if we change the format of the of the output? What if there is change in the format? Now the values are not underneath, but the values are on top. So what will happen? Still the rule will remain same. Rather than going downwards, we'll go upwards. But how? Let's have a look. Now what is this 0.793? This 0.793 is actually your square root of AVE. This 0.793 is the square root of AVE. AVE of which latent variable? OL. This 0.793, what is this? This is square root of AVE for OL. This is square root of AVE for the construct OL. So what is this? This is the correlation of that particular construct with the other construct in the study. Since we have only got two constructs in the study, there are no further correlations. So this 0.633 is the correlation of organizational learning with organizational performance. Now, in order to establish discriminant validity, your correlation should be less than the variance or square root of variance extracted, average variance extracted. And in this case, your correlation is less than. What if it's higher than? Then there are discriminant validity issues. Then there is lack of distinctiveness between the constructs. In this case, we can see that square root of AVE for OL, which is 0.793, is greater than the correlation of that construct with the other constructs in this study. So this means that there is no issue of discriminant validity here. But there is no correlation underneath here because there are only two constructs. So there could be only one correlation. So you can change the format a bit if you want. So you can obviously bring this here from, and you can put it here. Now this value must be greater than the values that are above it. So this has nothing to do with up or below. It's just for your own understanding. What actually is this, the criteria is that the square root of AVE for the particular construct must be greater than the correlation of that construct with all other constructs. Simply speaking, if I have to write it, square root of AVE shall be greater than the correlation of that construct with other constructs in the study. Let me complicate this model a bit, just a bit, so in order to add to your understanding of it. Let me take this variable here. and let's rename it CC. Let me put it in here, and let's go and calculate it. And if we go to discriminant validity, let's copy it into Excel format and put it in here and have a look. Now this CC, this 0.786 is actually, what is this? Square root of AVE. Square root of AVE. AVE of which one? Which construct? CC. And this is higher than its correlation with all other constructs. It is, yes, 0.786 is higher than the correlation of CC with the other constructs in the study. Same is the case with OL, and OP does not require any comparison because all the comparisons have been previously done. So if you need a value or you want to compare, you can put these values from here and put it here. OP and OL, it's 0.631. OL and OP, the correlation is 0.631. So OP OL or OL OP, there is no causality in correlation. So you can repeat the values and put it in here. And same can be done with OPCC, and that is 0.570. Now this value is higher than these correlations. So we can say that your discriminant validity as per Forner and Larker criterion is established. Your discriminant validity as per Forner and Larker criterion is now established. Okay, now this is one criteria to establish discriminant validity. There are other criteria as well identified in the SmartPLS. Now, cross-loadings. This is another criteria. And how do we assess cross-loadings? Let's copy it into Excel format in order to make it easier to understand. Let's put it in here. Let's what is this? This is your latent construct. This OCC OL OP is your latent construct. Where is this latent construct in your model? Here it is. Let's see, OL CC OP, and these are the indicators of these latent constructs. So these are the indicators. CC1, CC2, 3, 4 up till 6 are the indicators of this CC. OL1, OL up until OL8 are the indicators of OL. OP 1 to 5 are the indicators of OP. Now let me do something here, but before going into that direction, now these are the indicators of which construct? CC. So if these are the indicators of this latent construct, they should be strongly associated with its own parent construct rather than any other construct in the study. This CC1, 2, 3, 4, 5, 6. These 6 indicators are actually measuring what? CC. So they should be strongly associated with their own parent construct. Same goes for OL1 up until OL8. Same goes for OP, and they should be associated with OP. So how do you assess whether discriminant validity is established using cross-loadings? So let's say this is CC1, 2, 3, 4, 5, 6, and they should load and they should be associated well with what? CC. So we highlight these 6 items here. OL1, and they should be OL1, 2, 3, 4, 5, 6, 7, 8. They should be associated well with their own parent construct. These 8 items under this parent construct. And finally, OP with this parent construct. Now what we are saying is, we are saying that these 6 items should load well onto their own parent construct instead of the other construct. If you were to put CC1 with OL or OP instead of its own parent construct, its loading should decrease. If you were to put OL instead of its own parent construct here, if you were to put it with CC or OP, its loading would decrease. Same goes for OP. Is this the case? Let's see. Yes. If we look at CC1 here, whose parent construct is CC, if you are loading CC like this, with its own parent construct, its loading is 0.759. If you were to remove this CC1 from its parent construct here and load it with OL, its loading would decrease to 0.606, although it's still substantial, but its loading decreases. And same goes for OP, and same goes for all the variables in the study. Like OL1 is loading well onto its parent construct instead of CC or OP. So you draw these comparisons and you see whether each of the item is loading well onto its parent construct rather than any other construct. Yes, they are loading well onto their own construct rather than the other construct. And the difference between loadings, for example, we can say, well, it's loading substantial, it's 0.606 and this is 0.759, but the difference is still greater than 0.10. So we are not going to go on that delete spree of deleting items just because the difference is, although not that great, but still there is the difference. It crosses the minimum threshold of 0.10. So this is cross loading, and if you look here, there is no problem whatsoever if we do the comparisons. So we can say that using cross loading, we can say yes, the discriminant validity is established. Now the third criteria, a really easy criteria, and if we go to PLS algorithm, we go to discriminant validity and we go to HTMT and we see this. Let's copy this into Excel format. And if you put it in here, have a look. Now if you look here, these values are less than 0.85. This is a more conservative threshold, and there is 0.90 as well. So if these ratio values, HTMT values, these are actually calculated based on the indicator correlations. There is a whole process behind it. So we are not going to talk about how the calculations are done, why the calculations are done. The objective of this session is to understand the software, how to use it, how to report it. Hopefully soon there will be videos on how to manually calculate HTMT. So we'll be talking about that later. But for now, let's understand this. Less than 0.85, yes. Less than 0.85, yes. Less than 0.85, yes. So we can say in our study, discriminant validity is not an issue and discriminant validity is established because the HTMT values are less than 0.85. Now, since we have now checked all these three ways to establish discriminant validity, again, how to report it? If we go on to our paper, and then I'll show you the thesis as well. So this is how you report those things. Now, moving on. The component used to assess discriminant validity of the construct is heterotrait monotrait ratio procedure. As indicated by Hensler 2015, to check for the discriminant validity, the most conservative threshold values of HTMT ratio is less than or equal to 0.90. In this study, all values of HTMT are less than the threshold of 0.90. Hence, discriminant validity is established. And here it is. Here is the table. I just copied it from Excel, copied it from SmartPLS, put it into my Excel, and then just paste it into my Word document. And see if you have a look at in here, just one value greater than 0.85, but still it is less than 0.90. So my discriminant validity was not much of an issue, because obviously these two constructs are lower order construct to similar higher order construct, so there is obviously sometimes these issues, but otherwise there was no issue. So this is how you can report validity, both forms of validities and reliability. If you are writing a thesis, again, do these separately. Define what is discriminant validity. This is how, for example, you define discriminant validity. Then each of the method is reported separately by first defining what the method is and how discriminant validity is established. So you report it like this, separate table for each of the methods. by briefly describing what the method is and how the reliability and validity is established. Same is for cross-loading. And if you look here, EE, these 8 items are the indicators for EE. And these items are loading well onto their parent factor instead of the other factor. See, the loading is higher here instead of here. Same goes for resilience. This is the other variable in the study, ER, and for the others as well. So this is how you do your discriminant of validity. Now, if there are any questions, I'll take the questions, or otherwise we'll have a break for, let's say, 10 minutes. So now, what we have done is we have done a very basic model, and we have assessed the reliability and validity for a very basic model. Now let's say, I hope everyone is back. Okay, now let's say this is another data, and this is another project. Now within this project, if I need to create a new model, so just select that particular, obviously the project, and right click, create new path model, or you can do it from the toolbar here as well. So new path model, let's say, let's name it WS, and here are the indicators. Now let me do another model, a simple model as well, just to revise the few things a bit. And let's say this is one construct, this is another construct, this is another construct, another construct, and let's say we are looking at this impact on this variable here. Let's rename it function F2, or right click to rename it UP. This is ATD function F2 AIC IR M. Let's arrange it a bit. Indicators to the right. Let's connect these arrows. And let's see the model, PLS algorithm, and start. Let's see construct reliability and validity. It looks all very good. Let's see the discriminant validity. This is good. Let's see HTMT. Now if you look at the Fornell and Larker criterion here, let's see the Fornell and Larker criterion here. Just copy it onto Excel, and let's see here. Let's enlarge it a bit, and the top value, this is your square root of AVE. Is it higher than the underlying values? Yes, 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 yes. This one, yes, yes, although very close but still higher. Yes. This one, higher, higher. So according to Fornell and Larker criterion, there is no issue. If you look at cross loadings, before going into cross loadings, let's go to HTMT. But if we look at HTMT, there are a number of reds here. These reds are there because these 4 constructs are subdimensions to one higher order construct. So that's the reason that there is a higher correlation, but still these HTMT values are significantly high, very high. Now how do you solve this problem? Obviously this needs solution. What if your reviewer or examiner asks you to report HTMT? Now what are the possible steps that one could take to solve this particular problem? So there are a few recommendations that one could use. So if we go back to cross loadings, we could see that there might be an issue of cross-loading, and we have to assess this. So how do we assess this? It's very it's easier to just get it into Excel format. It's much easier to read through the columns. So just paste it here. Again, you will only be able to paste it or export it if you've got license. Otherwise, you won't be able to do it. And let's highlight. So these three are the indicators of AIC. These four are the indicators of ATD. These three are the indicators of IR, M, and UP. So first of all, we'll see whether these indicators are loading well onto their parent construct in comparison to the other constructs. But let's first see the issue. Where is the issue? The issue is between AIC and ATD. So there might be certain items in AIC or ATD that are loading well onto other factors as well, instead of their own parent factors. So AIC, ATD. So AIC and ATD. So 0.884, it's loading well onto its own factor, and yes, quite well. 0.869, yes. 0.867, yes. ATD, AIC. It's loading well onto its own factor, and the difference is greater than 0.10. 0.826, obviously the difference with all the other loadings is greater than 0.10. This is good enough. This is good enough. This is good enough. So there's no cross-loading issue here. There's no cross-loading issue here. Look at this. Yes, 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 no issue. Same is the case with this one, and same is the case with this. So cross-loading is good enough. So it's meeting that criteria. Let's see another thing. Let's see the indicator correlations. Any AIC items having significantly high correlation with ATD, or any ATD items having correlation with AIC. So if you look here, the correlations are not that high, not over 0.85. Just hold on. So AIC with ATD, it's good. AIC with ATD, it's fine. It's fine. It's fine. But the overall correlation, the composite correlation, might be high. That's the reason there could be discriminant validity issues. But if you are looking into the cross-loadings and Forner-Likert criterion, we see that there is not much of an issue. If you look at the VIF values, there is no multicollinearity issue as well. Now, what would you do in such a case? You still have got the data. I've got data from 784 respondents. I can't just go back and recollect the data. In this case, you will have to justify to the reviewer that you are going to go with what you have. You will have to report your Forner-Likert criterion. You will have to report your VIF values. You will have to add a comment on your indicator correlations. But if your HTMT value is high, this is how you can report it. So, but if obviously the problem, if it was to be solved, this is the way you normally solve it. You look at the difference of loading of the construct within its parent construct and with the other constructs as well. So if the difference, because see this is the issue. The loadings are substantially high on the other constructs as well. But you can't go on and delete all these 4 ATD items. You might be able to, or you might remove just 1 or 2, but I don't think so that would solve the problem. Maybe just 1 or 2, yeah, ATD 3 or 4, because they are loading quite well onto the other factors. That might affect your content validity. See, it's loading well onto M as well, 0.881 and 0.748. So the difference is less than, it's less than 0.15, but it's greater than 0.10. So if you were to remove these items to establish HTMT criterion, then you will have to obviously look into your content validity as well. So this is how you can troubleshoot your model for weaker or bad HTMT values or discriminant validity issues that you go into and look into the loadings and cross loadings. Now, what if your square root of AVE is low? There might be a case that your square root of AVE is low. This one is low, lower than all the other values. Then what we'll do is we'll go to outer loadings and see if our outer loadings are good enough. What if there might be a loading that is less than 0.50 or maybe 0.40? So then you can only remove the item just to improve one of the issue, to improve the square root of AVE. So you can remove, like the normal threshold is that if you've got, like, say you can remove 10% of the items. It's very important that you keep note that when you are preparing your questionnaire, each of the construct within your questionnaire must have at least 4 indicators. Not long ago, a lady doing PhD from Pakistan contacted me, and she had this issue of discriminant validity. And once she showed me her model, she had only 2 or 3 indicators for each of the construct. Now, if she goes on deleting 1 or 2, then the whole construct's content validity is under a severe issue. So you have to prepare early for these sort of things. So whenever you are developing your questionnaire, finalizing your questionnaire, do not use constructs with only 3 or 2 items. Give yourself space and always have at least 4 to 5 indicators. So this is something that one should be cautious when they are preparing their questionnaire. Now, this is all about your measurement model. Now you have established your reliability, you have established your validity, and you have reported it in the paper or in the thesis as I've done it here. Now the next step is your structural model. Now once you have done this reliability and validity assessment and now you have reported your results, the next step is to perform your structural model. Your structural model assessment to assess how your variables are interrelated with each other, whether there is a significance of relationship between 2 variables or not. Now in order to do this, what you need to do is you need to run bootstrapping procedure. And in the setup, you've got how many subsamples do you want. Now one should use a more larger subsample. These randomly drawn observations should be higher. So in order to get more adequate results and remove the bias in your results. So normally the recommendation is 5,000. But for this, because obviously if you got 5,000, if you go to 5,000 subsamples, 5,000 observations calculated randomly based on your sample size of maybe 784 in this case, or 341 in this case, sorry. So that will take much longer. So when you are doing your analysis for a paper or for thesis, go for 5,000. For now, we will keep it to 500. Select complete bootstrapping to have all the results. Now, if you know the direction of relationships, use one-tailed, otherwise use two-tailed, and you can check for the differences of results as well. Normally, the results might not differ that much, but sometimes they will. In my experience, when I use Amos or M+ or these softwares, even a deletion of one single item can improve the loadings of other indicators as well. But in Amos, since it's not common factor model, it's composite model, variance or the total factor structure is taken into account, there is very little difference. But that is too complex for now to discuss. Let's take a 2 sample for now. Go to partial least square, obviously make sure path is selected and press start calculation. complex the model, the higher time it will take. In this case, the model is simple, so it's taking lesser time. Now, the first thing that you will see in your results is the path coefficients. This is your original sample, path coefficient based on the original sample. This is sample mean, path coefficient based on your bootstrapping results. This is your standard deviation or standard error, T statistics, and PA values. Now, as with all the softwares, statistical softwares, you will get a number of hundreds of different results. Okay, this is significant, does not stoop in a zero. This one does not stoop in a zero. Samples, so it will give you a number of different results. You do not need to interpret, report, understand, give logic to all these results. As a business management student, I always tell my students, just focus on the results that you are interested in, just focus on the results that you need to report. Something that is required by your examiner, something that is required by your reviewer, something that is normally reported in a research paper or thesis. You should have obviously good grip or understanding of those results. Rather than focusing on everything and losing the plot, losing the other important bits, focus on something that is very important. In this case, let's see how we understand or how we interpret our results. Now, this is our model. Here, this is our IV, this is our DV, this is another exogenous variable, CC, IV, we can refer to it as IV, this is our DV. The R square is 4.428, 42.8% change in OP can be accounted by OL and CC. Now, is this effect significant? Is this effect significant? Now, what is this? 7.390, 3.902. These are your T value, T statistics. Previously, in SmartPLS2, you only used to get T statistics, not P values, probability values. So if your T value is greater than 1.96, you can say that yes, your relationship is significant. If it's less than 1.96, you can say your relationship is insignificant. In this case, both these relationships are significant. There is a significant impact of OL on OP. There is a significant impact of CC on OP. So both your hypotheses are significant. How? Because the T value is greater than 1.96, and this is your hypothesis. CC impacting OP. The beta coefficient is 0.24. Is this weight, is this impact, is this weight of impact significant? Yes, it's significant because the p-value is less than 0.05. So just for those who are new to statistical significance, whenever you are testing a hypothesis, since it's a test, since hypothesis is a proposition that is either accepted or rejected, although we never accept a hypothesis, we reject or fail to reject, but that's another discussion for now, just leave it. Just to make sure that it's easier to understand, you either accept a proposition or you reject a proposition. You accept a hypothesis or reject a hypothesis. Now, if you want to, or if you have to accept the hypothesis, the p-value should be less than 0.05. or equal, and if it is greater, you can say the hypothesis is significant, supported, relationship is significant. So the relationship that you wanted to test is significant. In this case, what we will say is that there is a significant impact of organizational learning on organizational performance. There is a significant impact of collaborative culture on organizational performance. Why is it significant? Because the p-value is less than 0.05 and your p-value is greater than 1.96. All right. Now, one more thing here. How do you report it then? If you're writing a thesis, it's very if you're writing a paper, it's pretty easy. It's just 1 or 2 paragraphs. Now, what structural model does is the structural model displays the relationships, paths between the constructs on the proposed study model. The proposed study model, your conceptual framework or your theoretical framework. Now, what H1 does is now you report each one of the hypotheses separately. H1 evaluates whether entrepreneurial leadership is positively related to project success. The results revealed that EL has a significant impact, total effect on project success. This is your beta value, this is your p value, this is your p value. Hence, H1 was supported. H2 evaluates whether EL has a significant impact on KM. The results show that EL has a significant impact of KM. How it is significant? This is your beta value. Where is your beta value? This is your beta value. This one here. This is your T value, this is your P value, and this is how you report in just one single bracket. And obviously you can then present the results like this in a single table. H1, H2, H3. These are the relationships that you want to test. These are your path coefficients, standard deviation or standard error, T statistics, and P values. And this is the description of the hypothesis results. Now, this was a very simple model. What if you've got mediators in your model? How do we test mediation, or how do we do mediation analysis? Now, mediation, as we discussed yesterday as well, mediation is like this: A influencing B, B influencing C. What we are actually saying is that the influence of A on C is actually through B. In a simple example, let me give you a brief understanding of mediation. Let's say I work in an office and we presume that if internal service quality is good, like if the service received within the organization between different employees is good, this will obviously lead to improved external service quality. This is very simple opinion about the relationship. This is too simple a view of the organization, of what is happening in the organization. In actuality, it doesn't work like this. In actuality, it is that if there is improved internal service quality, there is improved coordination between people. If there is improved coordination between people, there is lesser stress within the organization. If there is lesser stress between the within the organization, there is a timely response to queries. If there is a timely response to queries, then the customer is satisfied. And if the customer is satisfied, obviously, or if the external service quality improves, then the customer is satisfied. So the movement from internal service quality to external service quality is actually through different pathways. It's not as simple as mechanism that, okay, internal service quality is good, so external service quality is good. There are multiple intervening variables involved. There is a causal chain of relationship. So what mediators do is they explain this causal chain of relationship. They explain the mechanism of impact of IV on DV. They help you explain how an independent variable is actually influencing the dependent variable. Just the way I've done in almost all of my papers. Just the way it is done in this paper. We are saying yes, that entrepreneurial leadership explains improvement in project success, but this is not direct. One of the mediator in the scope of this study was knowledge management processes. In another study, this one here, it was different enablers leading to project success. Here the knowledge management processes were 7. And 2 enablers were taken: entrepreneurial leadership and knowledge-oriented leadership. In another paper, there are different mediators, and if you go on and search the literature, you will find at least 20-30 papers on linkage between CSR and loyalty, and they all have taken different mediators. So when you can be searching for mediators in your study. This is one of the way to discover new knowledge that we discussed yesterday as well. Same is the case with this study. Yeah. Here the mediators are team-based outcomes, and the gap revolved around mediation, that nobody or there is very little research on the mediating role of team outcomes between CSR and OP. So how do we test these relationships? In order to test such relationships, we do have to do mediation analysis. So let's go for mediation. Now this is a very simple mediating model where OL is your independent variable, collaborative culture is your mediating variable, and OP is your dependent variable. So what we are saying is that the impact of OL on OP is not actually direct. It does not happen that when you have got increased learning within the organization, the performance of the organization will improve. Rather, what happens is when there is learning within the organization, the culture of the organization improves. And that actually leads to improved organizational performance. So this is the concept of mediation. Now, how do we test this mediation analysis? Simply, you go to calculate, bootstrap, and start calculation. Now, when we are doing mediation analysis, we have to take into account three effects. We have to take into account total effect. We have to take into account direct effect. But since we are doing mediation using SmartPLS, the first thing that we look into is indirect effect. And then the type of mediation can be assessed using these, but obviously sometimes do not have to just report the type of effect as well, but sometimes the journal might ask you to do. Now the first thing, you do not even have to maybe link, because recently, or obviously when you are using SmartPLS, the Preacher and Hayes method, the indirect effect analysis, you do not have to actually link the direct effect as well. But if in the scope of your study you want to assess the direct effect in presence of the mediator, obviously you will have to draw the line. But if you're using SmartPLS, it's not required. And in one of the recent papers, it was mentioned that you do not check the effect of or the direct effect. You just, when you have mediator, you can just go for the indirect effect. But if it is not like, it is not banned. If the scope of the study asks you to check for the the direct effect, you can do that. No problems, no worries. Now moving on. So once you have run your bootstrap, the first thing that you do is you go for specific indirect effects. And this is your causal chain of relationship that you wanted to check in this study. OL affecting CC, CC affecting OP. Now the original sample is 0.171. Normally if it's greater than 0.10, the results might be significant. Normally, but sometimes even if it's greater than 0.10, still your p-values are insignificant. So is there mediation? Is there indirect effect? Yes, there is indirect effect, because the t-value is greater than 1.96 and your p-value is less than 0.05. Yes, the effect of OL on OP is through another variable, which is CC. Yes, the effect of OL on OP is through CC. There is an indirect effect of OL on OP. So this is how you establish whether or not there is an indirect effect of one variable on another variable. This is one part of mediation. Now what if I ask you, what if the reviewer asks you to identify if it's total mediation or complete mediation? Let's say use the proper word, complete mediation or partial mediation or no mediation. Obviously in this case the indirect effect is significant, so there is no point of focusing on no mediation because there is mediation. Now how do you assess complete mediation or partial mediation? Before going into that detail, let's look into these three types of effects. Indirect effect. What is your indirect effect? The effect of OL on OP through CC. Is it significant? Yes, it is significant. So indirect effect is significant. This effect is significant. What about your direct effect? So what is direct effect? Direct effect is the effect of IV on DV in presence of the mediator. So when the mediator is affecting the relationship, rather I should not use this word, when the mediator is present in the relationship and you are evaluating whether the influence is passing through this third variable, is there any direct effect as well? Is there some effect that is being passed directly and some effect being passed indirectly? So how do you check this direct effect? You have to go to path coefficients here. And if you go to path coefficients, you will see that OL and OP is significant. So there is some effect that is passing through CC, but effect is also passing through this direct effect here. It's also there. OL and OP, this path is also significant. So when this path is also significant, direct effect significant. So we do not need to check the total path effect as well, but we can check as well. The total effect from OL to OP is significant. Now all three are significant in this case. So this shows that this is partial mediation because some of the effect is indirect and some of the effect is direct. Now what if with the inclusion of mediator the direct effect turned insignificant? What if with the inclusion of mediator what if this is the case? With the inclusion of mediator, the direct effect of IV on DV is insignificant. So this amounts to complete mediation. All the effect of IV on DV is now passing through your mediating variable. In order to report this, it's very simple. This is how you report it. So you report your total effect, you report your direct effect, and you report your indirect effects. Now if you look here, the direct effect is significant. So you cannot say that it is total mediation or complete mediation. It's partial mediation in wherever it is. And in this case, there was partial mediation in this case here. This was partial mediation. All these, the rest were no mediation because the p-values are greater than 0.05. How do you write about it? It's pretty simple. Here it is. Mediation analysis was performed to assess the mediating role of team outcomes. These were the team outcomes. The results, the table, revealed partially significant p less than 0.10 mediating role of TI because it was around 0.05, slightly over. So if it's the p-value is considered like this, then it is partially significant mediating role. TE insignificant, TC insignificant, but your TP was found significant. It has a significant mediating role. And here, by looking at the table, you can easily identify which one are complete mediation and which one is partial mediation and which one is no mediation at all. I hope the concept of mediation and how to test mediation in SmartPLS would have been cleared. Now, if there are any questions, please. Yes, please.
Sir, can you just start with some more on the total effect and direct effect?
Yes. Okay. Now the total effect is the effect of IV on DV without the presence of mediator. For example, if I delete this here, and now there is no mediator in the model. So this is the effect of OL on OP, and this effect here will be referred to as total effect. Let me put it in here, and then I can share obviously the text as well. So total effect, the effect of IV on DV without the mediator in the model. This is your total effect. Now what is direct effect? Direct effect is one when you've got mediator in the model like this. So some of the effect may be passing through this path here, and some of the effect may be passing through this path here. But the effect, you have to not look into the effect that is passing, you have to look into the significance of the effect. Now that the effect of OL on OP in presence of this mediator, because there is this path as well, now this is referred to as direct effect. And where is this direct effect in the model? Let me run the model again, and I'll put the text there so that I can share it with you people later. Direct effect, the effect of IV on DV in presence of the mediator. What is, okay, this is your direct effect. Now this is the effect of IV on DV through the mediating variable MV. So what is mediating variable or indirect effect? Now this is your direct effect, the path coefficient. And what is your indirect effect? The effect of OL on OP that is passing through this third variable CC. And where is it in the analysis? It is this specific indirect effect. And this is significant. But your direct effect is also significant. See, OLOP. So some of the effect of OL on OP is passing through CS, like OL is influencing CC, CC is influencing OP. So some of the effect is passing through this path, and some of the effect is direct as well. I hope, Ali, now it's clear. If you've got any more confusion, please ask. I hope everyone is here. Okay, now the next thing that we are going to do is moderation. Now, where mediation actually explained the mechanism of impact of IV on DV, the concept of moderation is slightly different. Where mediation explains the relationship of how an IV affects the DV, or it's the causal chain of relationship between IV, another variable, and the DV. Moderation is about changing the existing relationship, or what changes the existing relationship, what molds the existing relationship. So a moderating variable is actually a third variable that changes. It can improve, strengthen, or weaken the relationship between the existing relationship between an independent and dependent variable. Now, in order to do moderation in SmartPLS, what we need to do is, here is my data set, the same data set, and let's see, I've got this variable here, CC, collaborative culture. So I did a pre-run, so it's role ambiguity, okay. And the dependent variable is organizational performance. Let's arrange it. Let's name it CC, and we'll name it OP, let's link the two variables. Now here is your independent variable, which is your collaborative culture. Here is your dependent variable, which is organizational performance. And now what I intend to check here is that I presume, or I hypothesize that the relationship between collaborative culture and organizational performance will be affected by a third variable, which is role ambiguity. This third variable here, let's rename it. Now this third variable, role ambiguity, will affect this relationship here. Now, how will it affect this relationship? It will weaken the relationship between, or the positive relationship between, collaborative culture and organizational performance. So role ambiguity moderates the relationship between collaborative culture and organizational performance, such that higher role ambiguity will weaken the relationship between collaborative culture and organizational performance. Now, how do you test mediation? So this is the relationship in which I want to test the mediation. So first thing is, you will connect your moderator with the dependent variable in the relationship in which you want to test moderation. So this is the relationship I want to check the moderation in. So you will link the role ambiguity with the dependent variable in that relationship. Now the model has turned blue, but still you haven't added the moderating effect. So how do we add the moderating effect? We either can do it from here, just select the variable and add moderating effect here, or you can even right click on it and add moderating effect. Both ways are correct. So we'll add moderating effect. So what is our moderating variable? Our moderating variable is role ambiguity, and our independent variable is collaborative culture. Now there are three different calculation methods. There is product indicator approach, there is two-stage approach, and there is orthogonalization. Now we will use product indicator approach because your constructs are reflective. If you want to know more detail about these, I'll share a book chapter that you can read to find out which calculation method is to be used. So if you've got a formative construct, you can use this two-stage approach, and if you've got a reflective construct, and we'll be talking about reflective and formative in some time when you are discussing the higher order construct. For now, in order to just easily understand, since the arrows are pointing from your latent construct to your indicators, this is reflective. So we will use product indicator approach. The rest of it is fine. Just press OK. And see, here is your moderating effect added. Now it's better to rename it. Just right click, and once you hover your mouse around, you will find that the information is correct. Yes, the dependent variable is organizational performance. Yes, the moderating variable is role ambiguity, and the independent variable is collaborative culture. So yes, the information that I added during my moderation setup is correct. Right click on it. You can rename it moderation underscore RA between, let's say, CC and OP. Okay, so now your model is ready to run. So how do we run the model? Same thing, because it's a structural model. Go for bootstrapping, complete one-tailed path, and start calculation. Since it's a product indicator approach, I'll just hold on one. I'll discuss the product indicator approach in slight detail. It may take some time to run because moderations are a bit complex. Now, if you look here at the path coefficients and look at the moderating effect of RA, it's negative as expected and it is significant. So RA, role ambiguity, is moderating the relationship between CC and OP, and the moderating effect is negative. The moderating effect is negative, which means that RA is actually, or RA weakens the relationship between CC and OP. So the strength of relationship between CC and OP is dampened or weakened by RA as a moderator, or role ambiguity as a moderator. How do I know this? Because if you go to path coefficient, the original sample is negative. So there is significant moderation in this model. Now, when your moderation is significant, it's always a good idea to report it through slope analysis. Now, SmartPLS does offer its own slope results or slope chart, but there are other ways to do it as well. We are going to look at both of them. I personally find this one by James Gaskin a little easier to use. So we'll be discussing both of them. Just give me a second. Okay. So in order to get slope analysis, you have to go to calculate PLS algorithm and start. And here it is under the final results, simple slope analysis. Click on it and you get this slope. You click on it and you get this slope. And it's always a good idea to put it into Excel. It's much more clearer there. Okay, if you look at this graph here, now this is your IV, CC, collaborative culture, and this is your DV, organizational performance. Now the role of moderation, or you do moderation just to evaluate whether a third variable will significantly change the existing relationship between IV and DV, whether it will strengthen the relationship or whether it will weaken the relationship. Now, Now, in order to do this, you can review this chart. Now, if you look here, these are three lines. One is green, which means that when the role ambiguity is increased. Now, if you look at the red line, this is a role ambiguity at mean, like normal role ambiguity with no moderation involved. And this is when role ambiguity is reduced. Now, if you look at these three lines, you will find that this line is much steeper. The blue line is much steeper than this green line. So this means that when your role ambiguity increases, at low role ambiguity, at high role ambiguity, this is when your role ambiguity is increased. So this line here, the effect, the green line, if you look at here, this line where role ambiguity is increased, your results are not that steep. The change is not that effective. So when you increase the role ambiguity, the significance of effect of CC on OP may not be that high, because your increased role ambiguity is reducing the effect of CC on OP. This line is much steep because there is low role ambiguity. When there is low role ambiguity, the positive effect of collaborative culture on OP is increased. Now this graph, when you draw it in SmartPLS, is not that clear. That's why Ramaya and other experts, they use other Excel tools to draw these graphs. Now, what I've done here is I've used James Gaskin approach. If you look here, there are two lines. One is blue, which means or represents low role ambiguity, and it is much steeper. And the red line, the steepness is low. So the red line means high role ambiguity. So when there is high role ambiguity, there is not much of an effect of higher collaborative culture on organizational performance. But when your role ambiguity is low, there is more effect. The steepness is, look, this is high. So there is higher effect of high CC on OP. So with high RA, even if you have got high CC, when the role ambiguity is high, even if you have high collaborative culture, extremely good collaborative culture, extreme collaboration within the organization, your organizational performance won't be that high. But in the other case, look at this steepness. If your role ambiguity is low, your high collaborative culture will lead to higher organizational performance. So, role ambiguity moderates the relationship between collaborative culture and organizational performance. That is, role ambiguity dampens the positive relationship between collaborative culture and organizational performance. It weakens the positive relationship between collaborative culture and organizational performance. So that if your role ambiguity is high, the relationship between collaborative culture and organizational performance is weakened. And this is depicted by the steepness in the lines here. Let's remove the negative sign from here for now, just to elaborate on this. Let's say the moderator was POS, the independent variable. So these are path coefficient from independent variable to the dependent variable here. This is CC to OP, independent variable to the dependent variable. This is moderating effect, which is, let's say it is positive. Let's assume it is positive. And this is the interaction. This is the interaction minus, or in this case, we are using the earlier value just to give another example. Okay, the effect of moderation, this is interaction, moderating effect, and the effect of moderator on the dependent variable, this is the effect of moderator on the dependent variable. So you put all these in here. For now, we are changing the value slightly just to do an example. Now have a look here. POS strengthens the positive relationship between collaborative culture and organizational performance. How? Look at this steepness. So if there is high perceived organizational support, there at low collaborative culture, you will have low organizational performance. At high collaborative culture, there will be higher organizational performance. Look at the steepness of this curve here, the red one, and look at the steepness of this one. Look at the change in the effect of CC on OP. The change is very little here when the perceived organizational support is low. When you improve or increase the perceived organizational support, the effects become more significant. So the line is steeper. There is a higher impact of collaborative culture on organizational performance. I hope now it's making more sense. Now these were the basic analysis that we did, and we used constructs at lower level. By lower level, I mean that you had a latent constructs and then you had the indicators. You had a latent constructs, you had the indicators. You had later constructs and you had indicators. But practically, when we are conducting our research at MS PhD level, we do not normally have a model with such simplicity. We have higher order constructs as well. For example, we might have one variable that is measured through different dimensions, and then those or each of those dimensions will have indicators. In such case, we will have to go for higher order constructs analysis. Now, how do we do this in SmartPLS? But before going into that detail, let me open a few presentations and we'll get going. Now, before we go into the detail of higher order constructs, to all those who have read about or studied SmartPLS or used SmartPLS, you all would have come across this terminology of reflective and formative indicators. What is reflective indicators and what are formative indicators? For the purpose of this workshop, we are going to only focus on higher order constructs and reflective formative indicators. But obviously, in future, we might do. Yes, I will share the chapter of moderation. Don't worry, all the material will be shared. So, what is reflective? What is formative? The ones that we've been focusing on, once we've been focusing on reflective. How come we say that these are reflective? Let me close this analysis to make things much more easier. Uh, the arrow is pointing from the construct to the items. So this is reflective. If the arrow would have been pointing from these items to the construct, this would have been formative. Normally, the studies that we do in that we see are first order reflective and second order formative, although there are second order reflective as well. There is a detailed paper, I'll share it as well, that has got a count of how many percentage of studies are first order reflective, first order formative, second order reflective, and there are 4 types of models. What is meant by reflective, formative, and what how do we identify that something is reflective or something is formative? Now, again, to a certain extent, not entirely, sometimes you can say that it is subjective whether your indicators should be reflective or formative. But there are guidelines, and most precisely, most of the times it is recommended that your second order factors shall be formative. Reason, we'll be talking about this in slide in a moment of time. Now, if you look here, we have already found that this is our latent variable and these are the indicators. So this is latent variable and these are indicators. The arrow is pointing from the latent variable to the indicators. So what is reflective versus formative indicators? The relationship between the indicators and the underlying construct can be formative or reflective. So the relationship between this latent construct and these indicators can be reflective or it can be formative. Latent variables are assessed by observable measures. Observable measure because these are the questions that are actually asked from the respondents. This is what makes them observable and this is what makes the latent variable unobserved. So the measurement model describes the relationship between the manifest variable and the latent construct. So these are the manifest variables, the indicators, and this is your latent construct. So measurement model is the assessment of relationship between these indicators and your latent construct. Now, what happens in reflective models? In reflective models, the indicators are affected by the latent variable. In reflective model, the indicators are affected by the latent construct. The arrows are pointing towards the indicators. Whereas in formative model, the arrows are pointing towards the latent construct. Reflective indicators are interchangeable. What do you mean by interchangeable? Since they are measuring the same underlying construct, there is a certain amount of similarity between the items in terms of their content. For instance, let's say the hotel you last visited checks the quality of goods and services provided to customers. It's helpful to customers and advises them about its products and services. Or respectful towards its customers. Now, all these 3 items are reflective because they can be used interchangeably. Even if you delete one of the item, the overall content validity of the construct is not affected. This is one of the criteria to assess your reflective or formative construct. If you are deleting an item and it affects the content validity, you can say that, well, it can be referred to as a formative. So the items are interchangeable. Formative indicators, the items are not interchangeable. If you delete one item, you are risking your content validity. A change in the indicators actually results in the change of the dependent variable, or sorry, the latent construct. I've got another example, social indicators, I think, yeah, HDI score. So let's discuss this example. So in a reflective model, the latent construct exists in absolute sense. Independent of the measure, the latent variable will exist even if there were 10 indicators and now you are left with 7. The latent variable will exist in reflective model because the items are interchangeable. Even with the deletion of one of the indicators, the latent variable will still exist. Practically all scales in business and related methodological text on scale development use reflective approach to measurement. Those skills that you see in the literature that you use in your for your questionnaire in your studies are more or less reflective. In contrast, formative model, the latent construct is dependent on constructivist, operationalist, and instrumentalist interpretation by the scholar. It's how you interpret your latent construct. It's how you define your latent construct. For example, HDI, Human Development Index, does not exist as an independent entity. Rather, it is composite measure of human development that includes health, education, and income. If you remove health from HDI, HDI is no longer present. It loses its existence. You cannot delete any single one of the indicators from HDI. HDI is a formative indicators. Health cannot replace education. Education cannot replace income. Income cannot replace the other two. So this is the difference between your reflective and formative indicators. This is how they are shown, reflective indicators and formative indicators. In order to make things simple for you, in your case, in majority of the business and management research, your studies are first order reflective and second order formative. Now, what is meant by first order reflective and second order formative? We'll talk about this just now. Now, moving on. Here are another example, or here is rather another example. So timeliness, if defined by accommodation in last minute or accommodate last minute's request, punctuality and speed, is reflective. Whereas life stress, if defined by job loss, divorce and recent incident, is formative. These three are not highly correlated to measure the underlying construct. They do not converge together. These are three different items. So that's why you call them formative. Deleting one of them might jeopardize the whole content validity or how you operationalize life stress in your study. Now, what is HCM? Higher order constructs or higher component models. Now, they provide researchers to model a construct on a more abstract dimension, referred to as higher order component, and its more concrete subdimension. So when you have got a construct in your study, let's say my study has this construct. My study has this construct, corporate social responsibility. And in my study, I have operationalized it as this. Now, these are 4 dimensions of corporate social responsibility. 1, 2, 3, 4. Now, these are the dimensions. You can say these are lower order constructs. And this is the higher order construct, corporate social responsibility. Corporate social responsibility is defined or determined by these 4 dimensions. These 4 dimensions are the lower order constructs, and this corporate social responsibility is the higher order construct. Now, in research, normally in business research, we take these as reflective, because the items that measure this lower order construct are interchangeable. This higher order construct is not reflective, because economic dimension cannot replace legal dimension. Economic dimension cannot be used in place of legal dimension. Economic dimension has got its own interpretation, its own meaning. Legal dimension has got its own interpretation, its own meaning. Ethical dimension has got its own interpretation, its own meaning. Philanthropic dimension has got its own interpretation and its own meaning. So you cannot say that, okay, if this one is deleted, still a corporate social responsibility can be measured. Maybe you have defined or operationalized corporate social responsibility as a four dimension construct. You have defined corporate social responsibility as something that has economic, legal, ethical, and philanthropic dimension. So you cannot say that it is reflective. That's why the studies that we do in using SmartPLS in business management, we keep the second order as formative. Although there are studies who have taken second order as reflective as well, published in very good journals as well. So both of them are correct. I'm not saying one is right and one is wrong, but this is the opinion that is being given by the experts. Now, what are the advantageous features? The advantageous features of doing higher order construct is that you do not have to assess each of the dimension or lower order constructs. Your higher order construct can obviously represent or is a representation of the lower order construct. So you have to check a minimum number of relationships than checking too many relationships. Now there are different higher order constructs. As I mentioned, there are four. You can have reflective, you can have reflective formative, you can have formative reflective, very least of like used. These two are you hardly will come across these anyway. So this one is, I think, the least one utilized, if I remember correctly from the reading in the paper. So I'll share this paper. It's a very good read after going through this workshop. I personally read it at least 3 or 4 times just to understand the concepts in more detail. So this is a very good read. I'll share the paper and you can have a look. Now, for this session, we'll try to focus on the first two because they are mostly used and much easier to analyze. Okay, now moving on, let's do our model. Let's do a higher order construct model. Let's say, okay, let's put it this way. Let's say this is our dependent variable, and let's say our independent variables are internal service quality. And internal service quality is a multi-dimensional construct. It has got 4 dimensions. Number 1 is reliability. Number 2 is assurance. Number 3 is empathy. Number 4 is responsiveness. And we rename it liability, assurance, empathy, responsiveness. Now these are the subdimension for a higher order construct. And what is that higher order construct? That is internal service quality. Internal service quality. Now let's say we still go for, let's assume we say that, okay, this is still reflective, like these 4 are now measuring this internal service quality and these are the reflections. in internal service quality. So what we do is just pointing the arrow from the construct to the dimensions. So if you look here, this is second order reflective. So reflective, this is type 1. Now this is red. Again, let's draw an arrow from here to here. But if you look here, this one is still red. If this would have been any other software, like let's say AMOS, you would have run the model. There wouldn't have been any problem. If you look here, this variable is still, or this latent construct is still red, because you haven't defined what is internal service quality. The latent variable has not or hasn't got any indicators. This is the error. So what are the indicators of this internal service quality? Actually, these are the indicators. But obviously these are by itself latent constructs. So these are the actual indicators for this internal service quality. So what you need to do is you need to have a second order model by adding all these into this construct. And look, now it's all blue. Obviously we hide it just to have a clear reading. Now what you can do is you just need to run this algorithm and then start. Now look at the construct reliability and validity, all good. This is also good, but is this acceptable? Can we use this as the reliability, validity and reliability assessment? If we go to HTMT or the discriminant validity section, look at ISQ. Can we use this? Because ISQ is a higher order construct. Can we use these measures? No, you cannot use these statistics for ISQ, the higher order construct. Reason is ISQ is determined or measured by these 4 variables or these 4 subdimensions. In this case, what SmartPLS does is it's measuring ISQ based on these indicators. Actually, these indicators are indicators of these latent constructs. ISQ is determined by these 4 latent constructs. So rather than measuring ISQ or the higher order construct based on these indicators, we should have measured it based on these indicators. So these are the indicators of ISQ. Now what you need to do is, so if you are using reflective, what you need to do is, in order to do discriminant validity or convergent validity for higher order construct, you have to transform this whole bit and represent ISQ with these 4 items rather than these items. So in order to do this, what we do is we go for two-stage approach. Although you can still calculate discriminant validity and convergent validity manually as well, but that will take too much of the time and it's a very complex process. Although I've got it all here, how to do it, all the calculations, I've developed the Excel sheets as well for this. All in here. It's all in here. But that it takes too much of a time if you do it without going for the second or two-stage approach. So we are not going to use this one, but we are going to go for a two-stage approach. So what is a two-stage approach? Two-stage approach involves transformation of the data. How do you transform the data? So once you have run PLS algorithm, you will see here under final results LVS, latent variable score. These are latent variable scores. And if you see, this will be 341 observation, just as you had in your thesis or the data in your thesis or your paper or whatever study you are doing. So what you need to do is you need to export this into Excel format or copy to clipboard in Excel format. So I'll do this and I'll open my CSV file, and since I've copied it, I'll put it in the end here as an extension to my already created data set. So I'll put it in here. No need for case ID. you can remove it. No need for higher order construct, ISQ, you can remove it and just save it. Now what we'll do is we'll go back to SmartPLS and we'll import that file. What I should have done is I should have saved it as another file, but both of the things are correct, but you save it as another file so that you can have two copies, or let's for now let's keep it. So import data file, your thesis data, open our file. Thesis data already exists, so let's rename it LBS. Okay, and here it is. If you look here at the end, you have those new variables in there. So what we need to do is we now need to see ISQ represented by REL, ASR, EMP and RES as its indicators. So we'll remove these, all the subdimensions. We'll remove this here, and now the indicators are added here. Now these 4 dimensions are the indicators of ISQ. Now this is two-stage approach. Calculate, PLS algorithm, start, and if you look at reliability and validity, now this is the right approach, and this is how if you've got a reflective model and you've got a higher order construct, so you can report the higher order construct with its reliability and validity like this. Now look at the discriminant validity. See, the problem is solved, and previously there was some problem. So this is how you do higher order construct when they are reflective. Now what if they are reflective formative? What if you've got second order reflective formative? Let's see if I can undo. No, I can't undo, so I have to redo the model. So let's say I've got OP as my dependent variable, and reliability, assurance, empathy. Let's remove this, I don't want too much of the data in here. And then you've got responsiveness. Now these are 4 dimensions of let's rename them. Reliability, assurance, empathy, responsiveness. Okay, now what we'll do is we need an indicator, and this is our ISQ. Now let's say ISQ is again obviously defined by these indicators. Now what I'm doing is I'm saying that this is second order reflective formative. First order is reflective, see the arrows, and second order is formative. Second order is formative because the arrows are pointing from the dimensions to the indicator. But if we run the model, there won't be much problem. See the path coefficients, See, there is not much of a problem here. But what if this ISQ is not an independent variable? As is the case, it may be a dependent variable or an endogenous variable. What if, see the variance, it's 1. This is the problem that we have when we have reflective formative. So we have to go for two-stage approach. What if, let's say, we've got another variable, let's say organizational learning. Now this is OP, let's rename it. This is, I think it was organizational learning. Now let's run the model. Let's go for PLS algorithm just to see the path coefficients. Now look at the path coefficients here. Look at this path. It's almost 0. Rather, it's actually 0. The whole variance in ISQ is being defined or explained by these 4 indicators. What's the reason? Because the indicators of these 4 subdimensions are actually part of this higher order construct like this. So this variable is not actually explaining any variance in this variable. You keep on adding independent variables and you will have similar results. The independent variables will not be explaining any variance in this variable, which is the endogenous variable here. So this is the problem if you go for normal analysis for a reflective formative model or higher order construct that is reflective or reflective formative. So what's the solution for this problem? There are 2 approaches, or rather extended repeated indicators approach. There is embedded two-stage approach and there is disjoint two-stage approach. Mostly the disjoint two-stage approach is followed, although recently Jackie Chia, Marco and other experts have been working on extended repeated indicators approach. For now, we will focus on disjoint two-stage approach that is mostly used and recommended. In order to do disjoint two-stage approach, what you will do is you will remove your higher order construct. You will remove your higher order construct and you will put your variables, your lower order constructs for a higher order construct, maybe in any order, just the way it seems easier for me to do it like this. So disjoint two-stage approach, there is a paper on it as well and I'll share it with you if you want to read it as well. So how do you do disjoint two-stage approach? Use connector and connect your independent with your mediators, each of your exogenous or independent variable with the mediator or the higher order construct. I'll take questions in the end, please. For now, if everybody can mute, please. Thank you. Now link this here. Now let's run the PLS algorithm. Assess the reliability and validity of everything based on this model. And now since we are interested in higher order construct, what we do is we go to latent variable. We've got these latent variable scores here. We go to copy it Excel format. Where is it? Just hold on. It's already there and it's the same score, 0.628 minus 1.626. Slight change. This is 1.633, but previously it was, or in when we had it as the other way around, it was slightly different. So when you are changing the approach, you should change your score as well. Obviously in this case our variables have changed as well, so we will remove this and copy it into Excel format. We'll paste it here. We do not need the case ID. The rest of it is good enough. We'll save it. We go to this and we import our data set. Let's name it with LBS. Okay. Now, the next step is we'll remove the higher order construct, and what we'll do is we have 4 dimensions of so these are the dimensions, and let's say we rename it as ISQ, and this is still reflective, so you need to change it to formative. So how do you do it? Just right click on it and switch between formative, reflective. Now it is formative. Let's arrange it. In disjoint two-stage approach, the lower order constructs will have their indicators as is. Let's do this, move this, link this. And now if we run the model, let's say we run the PLS algorithm, start, and if you look at here now, see the path coefficients have changed. Previously it was 0, it was 1 here and it was 0 here, but now since you have used the disjoint two-stage approach, the problem is resolved. But now the next step is validating your higher order constructs. Since you did validate your lower order constructs, how do you validate your higher order constructs? So according to that latest study by Marco Sastet, Ringel, Jackie, and Becker, I'll share the paper. There is a certain criteria that one needs to follow. And that criteria is this. You need to do validity based on collinearity and significance of outer weights. So where are these things? If you go to PLS algorithm and see VIF, so for empathy, assurance, reliability, and responsiveness, the VIF values are less than 5, so they are good, they are acceptable. So there is no multicollinearity issue here. This is one part of assessing validity of higher order constructs. So this is our higher order construct with 4 dimensions. So once you run, you go to the VIF collinearity statistics and you look at these values. And the outer weights is the significance of outer weights. So how do you check the significance of outer weights? You go to Bootstrap and then you run. And here it is, the outer weights. Look at this. Oh, there is a problem. The problem is that the outer weights are not significant for 2 of them, but they are significant for 2. So what shall we do? Shall we delete these 2 indicators for ISQ? No, because then again there is content validity issue. So what you should do is, the next step is I'll send you a chart as well that can help you. So what you should do now is you look at the outer loadings just above here, outer loadings. Are the outer loadings greater than 0.50? Yes, they are greater than 0.50. So even if your outer weights are insignificant and your loadings are significant, you do not go on and delete the indicators or higher order constructs. So in this case, we can say the validity for the higher order constructs or higher order construct is established. That is ISQ in this case. So this is how you analyze your higher order constructs, a higher component model, second order reflective for second order reflective or second order reflective formative models.